There were some technical difficulties with the website today, so we had to send out the Zoom links manually. So sorry about that. Let's get started though. All right, so today actually I have a lesson plan for us. What I really want to do, I want to go over a little bit here. I just want to go over some basic syntax, variables, data types, and I want to hopefully by the end of the day get to about here at the nested if statements. This is the this is the plan for today, but yeah, let's hope we can get there. Oh, but yeah, let's start with the different data types that there are. So in Python, there you have these things that are called variables. Similar to algebra, you have they're values that hold something. So in Python, a variable would be to initialize a variable. To create it, you would do something like this. You would say number equals, and then you just type a number right there. And now what this does is it assigns this variable this value. So whenever you reference this, it's gonna hold that value. So if I wanted to print, let's say I wanted to print 123, but I don't want to type out 123 every single time. I could just instead type out print number, and it'll print whatever that holds.
Hey, Luke.
This is useful in many ways. Yep.
Hey, how you doing? Sorry, getting to class a little late. Was trying to get everything situated because we were locked out of the initial way to get in. But could you kind
Yeah.
of repeat what you're doing as far as the first steps?
Oh, absolutely. Yeah. So right now, let me share this again. And yeah, sorry about the difficulties today. I don't know, the website's down for maintenance, I think. But today we're just gonna be going over data types, which I'll show you in a second, and hopefully get to about around here, around to if statements. But yeah, right now we're just going over the different types of the different data types that there are in Python. So this is this is what's known as an integer data type because it holds a whole number. Let me reference this real quick. So
Is it only an integer because it holds the whole number?
yeah, an integer is any whole number.
Okay.
It's yeah a number that does has no fractional part. As yeah actually as it states right here. Um, so you conversely you have floating points or floats, which are numbers, but they're not integers, so they hold a decimal. They're fractional. So that is what an integer is. Sorry, let me just move you guys there. Yeah, so you okay, so let me just do this. We okay, so this is gonna this talks about octal and hexadecimal numbers, but it's not relevant to what we're trying to achieve. So we're just going to for now just skip over that. Um, yeah, so floats. As I said before, floats are numbers that aren't whole numbers. So float would be this is an example of a float right here. It's a decimal. It's a fractional number, so it's represented as such. And actually, a float can also be I'm just gonna that's just the name I want to make for the variable. So I'm gonna assign this variable a float number. So
Can you
this
put the compiler back in the chat?
oh yeah, absolutely.
Thank
hmm And yeah, feel free to follow along as well. Um, yeah, so this is a floating point number right here. It doesn't have anything past so even though the decimal is empty, it's still represented as a floating point because you have the decimal point right here. Yeah, what is the difference between integers and floats, right? The decimal point is very it's key for recognizing what a float is in Python. So yeah, as you see here, you have these two numbers. What is this number right here? Does anybody know what data type this is?
I know it's a integer because it's a whole number, but I don't know.
No, that's exactly right. That's an integer, and yeah, this is a float. It's a float because of the decimal point here. So Python is always going to read it that way. If they see a decimal point, it's going to read it as a float. Yeah, so as it says here, it's what determines a float, the decimal point. And you can do this. This is optional. This isn't typically done, but if you want to use numbers that are very small, very large, you can use scientific notation, which which I honestly do not recommend, because you're not really going to be getting into that much. This talks more about exponents, exponential notation, and floats. But what I'm trying to get into today is the different data types. That's what I really want to focus on. So I'm just going to make a variable to represent another data type, and this variable is called name. I'm going to assign name what's called a string. That's the data type. So to represent a string, you don't do number, you don't do a decimal point, you do these two double quotes, similar to what you put inside of print sometimes if you want. So we'll do name and we'll just do Luke here. Name is going to equal Luke. So anytime I reference this, it's gonna what's gonna pop up here? Let's see, my name, right? Because that holds that. So strings are very, very useful. Especially we're gonna be getting into some exercises today with that
Can,
as
can
well.
you get it? Can you explain that one more time, Luke, please?
Yeah, so
Even can you start up there with the number equals one, two, three, and the fraction? I kind of zoned out a little bit. I was paying attention, but I just want you to, if you could just repeat that one more time so I can make sure I understood it.
yeah, sure. So what I did here was I created what's called a variable, and all these variables they need to hold something. So I made this variable right here. It doesn't matter. I can name it whatever I want, but I can even name it num. I made this variable equal an integer or an int. This variable right here that I made it equal to a float, and this variable is a string. These variables all hold data, so these are just representing what types of data they're holding here. Does that help?
Yes, sir. Well, and once you said variable, I was like, okay, that's what it is. These
Yeah,
are
yeah.
variables. Okay, I missed that part. I got it.
Gotcha.
Thank you.
Yeah, no problem.
And what's the definition for like a string again?
A string is one or more characters that are like they're represented by a string is represented by the double quotes or the single quotes around it. So they're just you can't really manipulate them. They're just what you see is what you get with strings, you know.
And it can
Um,
be single or double quotes.
yes, it
It
can.
doesn't matter. Okay.
Yeah. Well, there's certain trade-offs to using single or double quotes, but yeah, we'll get into that later as well.
Okay.
Um, Yeah, a string is essentially anything that is surrounded by surrounded by quotes.
Anything surrounded by quotes. Pretty much
Yes.
for got it.
And another thing as well that we have is what's called a Boolean. So I'm gonna make a variable here. I'll just call it true false. Like I said, you can call whatever you want. But to make a Boolean, you have to assign it a value. Um, this value is equal to true or false. And that's it. That's what a Boolean is. It's something that's either true or false. And this will come in handy in many ways, but
Now maybe I might be a little off, but tell me what are the why see how does this make sense? I don't want to make it sound so weird, but the variables. So what are the reasons for us using variables and when are good times and or should I say when will we know when to use them?
you'll know when to use them. So I'll give you some exercises like where we're gonna use them, but they're very powerful because you can do things with the variables. So let's do this real quick. Let's say I have the number 1, 2, 3, whatever number this is, 1, 2, 3, 4, 8, 4, 3, right?
Okay.
And what if I want to print this number, but I don't want to type this in to print every single time? What I can instead do is reference
Sounds
the
like a cheat.
variable.
It's almost like a cheat sheet, like a cheat for you in a way, or like a shortcut in a way.
Exactly, yeah, it's a shortcut.
Okay.
Exactly it.
So just
Um,
look at variables as like your shortcut to doing
exactly.
certain things. Okay, that way you're not having to type out everything every time.
Yeah, it
Save you
just
some
it
time.
makes it much easier.
Okay,
So
so
that's
pretty much
honestly,
working smarter now.
yeah, exactly. Yeah,
Okay.
and that's what programming is. It's working smarter, not harder. So that's why all these tools exist for you. So
Okay.
yeah, let's just
Now it's
do
okay. Okay, making sense.
yeah. And well, another thing we can do with variables is, and this is pretty interesting too. If let's say I want to just print this -1, all I have to do is type that -1. I'm sorry, 1 second. Let me just do that real quick, and it'll give me this number -1. So you can manipulate the variables too if you wanted to. And it's honestly it's huge for programming. Let's see here. Where am I? Oh yeah. So with strings are just to delve a little bit more into this. Strings like floats, they don't have to have this could be a string, right? Even if it's empty, it's still considered a string just because of the quotes that are around it. And you can still reference it as such. It'll say nothing, but there's still something there, if that makes sense. Yeah, so Booleans are very strange. They're binary, which means it's either one or the other, 0 or 1, true or false. Um, there's a term in programming that's called truthiness or truthfulness, which basically is so let me just backpedal real quick. Every time Python is asked if one number is larger than another, the result is the creation of a very specific data type, a Boolean value. So if you're comparing right here, then a Boolean type is created. The term Boolean comes from George Boole, the author of Laws of Thought. I have no idea what that is, which defines Boolean algebra, a part of algebra that makes use of tool values, true or false, otherwise denoted as 1 and 0. A programmer can write a program and the program asks questions. Python runs the program and provides the answers. The program must be able to react according to the responses received. So computers only know two types of answers here. If it's true or if it's false. There's no probably, maybe, there's nothing like that with computers. They're very robotic, of course. Um, so yeah, Python is the same way. It has trues and falses, and they cannot be changed. And this, yeah, and this is how you write them out if you want to reference them. So let me just show you guys here. So this is the variable, and it holds the false value. So it's gonna come up as false. Yeah, let's do this real quick, actually. Let me try to explain this. Due to the way that Python works, just the thought process behind it, when you compare true to false, this is what's known as comparison in programming. It this will essentially tell you the results. It's going to print the results of if true is greater than false. So if true is greater than false, it's going to say true, but if it's less than false, it's gonna evaluate to false because it's not less than false. I know that seems a little strange, but it'll make more sense in a second. So let me cover this more right now. If we want something to print true here, right? We're gonna write what's called a conditional statement, such as this. So we're basically what we're doing here is we're asking, does 10 equal 10? And if that's true, it'll say true. The way to compare two things in Python and Java and in many different languages is to use the double equals operator. Double equals is the only way to see if something is equal to something else. It's see if a number is equal to something else, just in vanilla Python. So we have double equals, we have doesn't equal, we have greater than, we have less than, and we have not. We'll get into not later, but these are what's called comparison operators. These are very, very, um, very valuable, let's say, when trying to compare things together. So does anyone think they know what would happen if we did this? What is the result of this? I'll give you a hint. It could evaluate to
Would it be
only true.
true?
It
Is
would.
that 10 equals 10 or 10 times? I can't really see just because it's a little
Oh,
smaller
sorry.
on my screen.
Yeah, yeah. I can zoom in for you. So this is less than.
Okay, so it'd be false.
It would be, let's say, it would be false. That's correct. Because obviously 10 is not less than 10. 10 equals 10. But if we change this up, we can do, we can ask it, is 10 less than or equal to 10? And that's going to evaluate to true. That's another comparison operator right there. Now the not symbol right here, this is asking, okay, is 10 not equal to 10? No, 10 is equal to 10. So not is it's a very tricky comparison operator. But it just represents the opposite essentially. So sorry, this is very outdated sometimes. Okay, so we went over this. We went over integers, floating point variables, Boolean variables, sorry, strings. So we're good on that. All right, so now we have
Hey, Luke, do you mind
just
going back to that screen so I can take a screenshot of that screen?
oh, which one? This one or
With the one with all the terms on it?
oh, sure, absolutely,
Oh, yes, please. Okay, you're good. Thank you.
no problem. And yeah, does anyone have any questions so far on any of this? I'm moving a little bit fast, so
Yes. What page would this be on if I was trying to follow along with this in the career maker? Is it in there?
this. Let me see. I'm not sure if it's in the Career Maker. I'm using something from Career Maker, but it's a different website.
Yes,
So
this is in the book PDF. You can just go to the page number. Look, can you please tell him the page number it is like under 2.3 101 operator tools for data manipulation. So you will see the same. LMS is working now, so
oh, it is okay, perfect. So yeah, it would just be 2.3.1.1. I'm not sure in the PDF what it would be though, but
yeah,
I
there
can
is a
confirm.
PDF in the course itself. If this Emmanuel, if you just go to your portal, Python training, then the left side is the options, the PDF. Yeah, look, you can just take a look here. Course delivery. Python subject, yes. Subject, yeah. Yeah. Python essential, just or the first one. There's a module two. Yeah.
2311, right?
Let's see the
Oh, sorry,
module.
right here.
Yeah.
Yeah, so 2.2. For the
Yes. So this
summer.
is the one. Yeah.
Yeah, so we previously when we looked at print, it kind of seemed one-dimensional before, yesterday, but today we're gonna be using it, and we're gonna see that there's a lot more to print than you would think. So we can actually use print for math. So if we wanted to print 2 plus 2, it's gonna print 4. It's gonna print whatever this evaluates to. If we want to do 20 times 2, the same thing, 40. Yeah, you get the point. It's really great for calculations. So we're gonna get into operators right now. An operator is a symbol which is capable of performing operations with values. In arithmetic, you have the plus sign, of course, which is capable of adding two numbers and giving you the sum. And the same thing for subtract and divide. But not all Python operators are as simple as the plus sign, such as the. Actually, no, let me. Yeah, so here we have some of the operators available in Python. The rules must be followed to use them, and how to interpret the rules they perform. So for example, we have all of these different operators here that are used in Python. Let me see if I can just copy it. Let's see if it'll be as simple. Okay, it is. We have the plus, which is, like I said, very, very simple. We have subtract. You have this. This is an asterisk, which means to multiply. If you want to represent multiplication in Python, this is what you use, an asterisk. You also have the slash, forward slash, or divide for division. Okay. And then I'll get to the other ones as well in a sec. So this is the double asterisk. This represents exponents, exponentiation. So let me see if I can give you an example here. Does anybody think they can tell me what the Does anyone think they can tell me what this will evaluate to here? 5 exponent 2. I know I haven't really explained much about it, but just curious here. That's totally fine.
Does it I'm gonna say does it double it?
So what this does is it says I have 5 here. I want to raise 5 to the power of 2. So 5 to the power of 2 would be
Because like square root or something?
it's sort of the opposite. So it's multiplying 5 by itself.
Okay.
So that's 25. If we were to do 5 exponent 3, that would say, okay, I want to do 5 times 5 times 5. And that would equal 125. And so on and so forth. So yeah, this is just for exponents right here. If you want to do anything with exponents, you represent it with double asterisks.
That's a little tricky.
It is, yeah, it is a little bit tricky. Let me see if I can better explain. The argument, okay, so in this right here, they did the same thing. They have 2 double asterisks 3. This I can rewrite this here. So this is just saying if this will even work properly. Let's see. This is saying I want to multiply 2 by itself 3 times. If we were to do 2 double asterisks 4, it's saying, okay, let's do that 4 times now. So for this, in this example right here, this is just saying, all right, what's the results of 5 times 5 times 5? That's how you get 125, because you have the 5, and then it's multiplying by itself 3 times. Let's okay, what if we do this? Can somebody tell me what this is going to equal?
Damn.
16.
Sorry? 16. Yep, that's right. And why do you think that? Why is that?
4 times 2 is 8, and then 8 times 2, 16. So you're multiplying it by 2, I guess 3 different times.
So it's not. You're right, but for the wrong reason, unfortunately, because it's not. We're not doing 4 times 2. We're doing 4 times itself.
4
2 times.
times, 2 times, yes.
Yes, exactly.
Okay, okay.
And if we were to do,
Are you doing what? 4 times? Say it one more time. What are you doing? 4 times 4, 2 times?
yeah, 4 times 4, 2 times. So, but for this now, we're doing
4 times
Four
3.
to the third.
64. That's 64.
That's 64 because it's 4 times 4 times 4, or 4
It's
of
multiply
itself.
4 by itself 3 times.
Yes.
Okay.
Yeah, just
I'm
wanna
forget
just
that. I'm
before we
gonna
move
write
on.
that one down.
Yeah, that's it's a little bit strange. There's a lot of algebra in Python, so exploits are a little bit tricky.
Is it the same thing as in mathematics when we are doing elementary? You say 4 raised to 3. 4 raised to
Yes,
power
yep,
3.
exactly. It's to the
Exactly.
power of 3. And that's what we're representing here. This is saying, okay, 4 to the power of, and 3. Let's do one more before we move on, because I really want to get this. Let's do 2. So 2 to the power of 3. Does anybody know what that would be?
Eight.
It'd be 8. Yes, it would be 8. But why?
Because it's 2.
That is
You're doing it
multiply
3
2
times.
3 times.
2 by itself, 2 times
Itself
itself
3
3 times.
times.
Yep, exactly. Yep. 2 times 2 times 2. So that's 8. Perfect.
That's okay. So that's where I get confused at. When you say
Oh,
2
okay.
times 2 times 2.
Yes. You have the 2 here, so this is what's called the base. This is the number that's going to be multiplied by itself. And then here you have the exponent. So this means you're going to multiply the base by itself exponent times. So in other words, you're going to multiply 2 by itself 3 times. 3 just represents the number of times you're going to multiply the base by itself.
It's gonna be gonna take me some time to get used to this. And this is the operator, right?
Yes. Yep. These
Okay.
are, yeah, this is a basic, I think it's called basic operator. Yeah. Arithmetic operator. So okay, if we were to do this really doesn't matter too much here, but if we were to make this a float instead of an integer, it's going to evaluate to a float. Any float multiplied by an integer is always going to be a float. So just, no big deal. You don't really have to remember that, but it's good to know. We did this. We did the multiplication operator. So we can move on to the diagonal or division operator. Diagonal symbol is a division operator. The value after the diagonal is the dividend. So what that means, the 5 here would be, this is what's called the dividend. Okay. The value before the diagonal is the divisor. So 10 divisor, 5 dividend. This is going to evaluate to 2.
Oh.
And notice how it returns as a float. That's because when you're dividing, it's Python prefers to return it something as a float as opposed to an integer. So let me copy this right here. So let's run these examples right here and let's see what happens. See, it's always going to be a float here. These are all the same numbers, but one's a float, one's an integer. They're always Sorry, can you mute your mic, Emmanuel?
No.
I'm just gonna mute real quick. Okay. Let's see. Yeah, so result produced by the division is always a float, regardless of whether it's two integers, one integer, what have you. And yeah, sometimes you do run into problems because of that, but there is a solution in Python that can help with that. We have another arithmetic operator, which is the double diagonal, which is the integer division operator. It's different from the standard operator in that it'll return an integer instead of a float every single time. So this is pretty strange, but let's try running these examples here. What do we think this is gonna evaluate to? What exactly? Okay, well I will tell you guys, this is gonna evaluate to 2 because we're saying 6 divided by 3. The double slash here just means whatever is going to be returned is going to be an integer, not a float. What's going to happen here? This is weird. We have an integer and a float, but we also have a double divisor. Let's find
So
out.
would they be? They would all be 2, just because the double, um, I guess the double division sign makes it an integer.
Exactly. Yep. That's exactly what a double division sign does. However,
Say that one more time out.
so the double division sign prefers resulting in an integer instead of a float. Notice here though that because we have a float here, that it's still going to return a float. Let's see what happens when we do a float in the beginning. Same thing. Because we have a float somewhere, it's gonna return a float. Double floats, it's a float again. But when you're using two integers, it's gonna return an integer every time. So now we're gonna do something a little bit tiny bit different. We're gonna do 6 double divisor 4. That's gonna return a 1. Why is that? Why doesn't it just return 1.5? That's because we have the double slash here, it's always going to return um, the value rounded. So 6. So it's basically going to cut off what this is. If there's anything after the 1, it's going to cut that off and return that instead. Same thing here. It's going to say, it's 1.5, but it's actually not. It's going to return 1, but again, it's still going to return it as a float. It's very strange, but and also it's really good to know that rounding always goes down. Rounding in Python never goes up. So if something is 1.5, it'll always round down to 1. Now, next we have modular division. Modular division's pretty strange. It's not too hard though. It's a very tricky operator, but because it doesn't have an equivalent in algebra or any real world situations. I guess it has the percent actually represents the remainder. So if we were to do this, what's going to happen here is it's going to give us the remainder of 10, and we call this mod. So 10 mod 3 is 1 because it's going to say, okay, 3 goes into 10 3 times, but there's still one number, there's still 1 left. There's still 1 remaining. So it's going to give us that 1 as a remainder. If we want to do 10, 11 mod 3, the remainder will be 2. So let me see if I can better explain that here. Yeah, so the result of the operation is the remainder that remains from the entire division. So it's the value left over after dividing one value by another to produce an integer result. It's, yeah, the operator is also sometimes called a module in other programming language. It's just in Python though, it's not. Does anyone think they know what happened if we did this? Knowing what we know. 14 mod 4.
And
I'm sorry?
10.
It's so it's not going to be
Okay,
10.
one.
It's going to what? 1.
Is it going to be 1?
I
So
was
it's
gonna say
going to
2.
be, yes, it's going to be 2, and that's because 4 goes into 14 3 times, but but 4 doesn't go into 14 4 times, so you still have that 2 left over. So let me just write this out.
Well, you said 4 going to 14 3 times.
Yeah. So we're not. So basically, it's kind of hard to explain. So
So why wouldn't
if
it be
you're,
1 and why is it 2?
it's 2 because 4 times 3 is 12, right? But 12 doesn't, there's still 2 left from 12 that has to go, that
Ah,
to go to
okay,
14.
okay.
Yeah. So it's the difference between this and that, essentially.
Can you do one more?
Yeah. We'll do 15 mod 4. What is that?
1.
It wouldn't be 1,
I'm gonna say,
and
is it 2?
it wouldn't be 2, it'd be 3 because
3.
Oh yeah,
remember,
It's going to be 3.
yes. Because 4 goes into 15 3 times, it can't go into 15 again, so we're stuck here. We're stuck at 12. And the difference between 12 and 15 is 3. So that's all that is.
Okay.
It's actually not correct.
And instead of like, I guess it would be easier to run that than to actually do the math.
Oh yeah,
Is
absolutely.
that something? Okay.
Yeah, so 15 mod 4 is 3, and then we'll just do this we'll give you a couple more examples here. What happens if we do 16 mod 4 though? What's that gonna be?
0.
It's gonna be 0, that's right, because there is no remainder anymore. 4 goes into 16 4 times, and then that's it. 17 mod 4 is going to result in a 1.
1.
Yes. Exactly. Yeah, so hopefully that makes sense. It's the first time I learned modular division, I was not at all excited about it. It didn't really make too much sense to me, but just through trial and error, it like you'll start to understand it a bit more. Same thing with exponents. So
How long did it take you to start learning that? I know it just clicked with you. I know it took you a little bit, right?
yeah, absolutely. It took me like a couple months actually, to just like,
Okay,
because I
good,
started
okay.
out in Java a long time ago. Yeah. So this is moving relatively fast compared to how I learned. So we have the addition operator next. I guess we can look a little bit into this. Does anybody know? We're gonna start out with something tricky. Does that? What is that gonna equal? -10 plus 5.
Is it 5 or -5?
It is, yeah. It is
Negative
-5.
5.
Yes.
I'm not the smartest with the math, but I know it's either one of the two, either 5 or -5.
Yeah,
I thought it was a trick question.
kinda. Yeah, so yeah, it's -5 and it's just -10 plus 5. That's, I mean, that's what if we do this though? -10 minus 5.
-15.
That's correct. Yep. Yeah, so negative minus negative, you're basically adding them up and then putting a negative next to it. So all right, let's see. This goes into, okay, yeah, unit. We can do this as well. I suppose negative float. That's just going to equal -15.1. It's very simple, honestly. The plus operator and the minus operator. So you can skip that for now. Let's see. Yeah, until now we've looked at the operators themselves. We haven't treated them as if they had any relationship to each other. Um, that's pretty rare though in programming. Sorry, 1 second. Yeah, very most of the time you're gonna find more than one operator in an expression, and then it's not gonna be so easy for, you know, these operators aren't really they're gonna start being a little bit more confusing. So let's consider this operation right here. Where do we even start with this, right? 17. Does anybody know why that is? This is more of an algebra question than a programming question, but reason why
Multiplication comes before addition.
exactly,
3
yep.
times 5 is 15 plus 2, 17.
Yeah, so that's because of something that I learned called PEMDAS. PEMDAS is just derives from algebra. It stands for this is called the order of operations. So you evaluate something by its parentheses first, then by exponents, multiplication, division, addition, subtraction. So that just means when you have a case like this where there's addition and there's multiplication, you're gonna go down the list here. You're gonna see multiplication. Oh, that's before addition. So we're gonna do this first, and then next we're gonna do the addition. If we have Can somebody tell me what this is gonna be using PEMDAS?
14.
It would. So it's not. Oh, sorry. It is gonna be 14. I'm sorry. Yeah. No, you're right. Absolutely. It is 14. And I was trying to get 40 from this, but let's do. And I'll print this out too, actually. Let me just comment these. While I'm doing this, what is the result of this gonna be?
22.
40. Oh yeah,
This is
22.
going.
Yeah,
22?
Yeah. Yep.
yeah.
22. Let's run it. 22. Yep. So yeah, using PEMDAS, it's pretty, it'll start to just come to you naturally what to do. You're not really gonna have to think about this every single time you're looking at something like this. But yeah, in this case, that's 22. So the binding of an operator determines the order in which the operations of operators with the same priority, which are within the same expression, are computed. I know that's a mouthful, but just bear with me here. Um, most Python operators have left binding, which means that the calculation of the expression is performed from left to right. So, for example, you have something like this. The calculation, because these are both the same operators, the calculation is just going to go from left to right. So we're going to do 9 mod 6 mod 2. The result is going to be a 1, in case you're curious.
Can you go over how it's one?
Oh yeah, absolutely. So from left to right, you have 9 mod 6, which results in 3, because 6 goes into 9 once, and you have 3 left over. And then you have 3 mod 2, which results in a 1. So let me... Just to break it down here, you have that equals a 3. So it's saying this mod 2. So this is 3. 3 mod 2 is 1. Because 2 goes into 3 once, and then you have 1 left over. Does that make sense?
Yes.
Okay. Let's do this then. Actually, let's do... What's this gonna be?
Who?
2.
I believe this is gonna be 0, but yeah, it's going to be 0 because we're doing... let's do 10 mod 6. That's a 4. And what is 4 mod 2? That's a
0.
0.
Yeah,
Yep.
that's okay. 0.
Yeah.
And
So
because
that's all that is.
it's because 4 can't go into 2, right? So it's 0, right?
Exactly, yeah. So yeah, 2 goes into 4 perfectly, and there's no remainder, so it's a 0.
What about the 10 and the 6? How'd the 10 go into 6?
Oh, so 6, okay, so 6 goes into 10 once, and then there's 4 left over. If that makes
Okay, so at the
sense.
bottom, it won't be the 2 going into 4 at least once.
The 2 goes into 4 twice, because it goes, you go 2 and 4. So it divides evenly. There's no remainder. This doesn't divide evenly. It's not very clean, so there's going to be some numbers left over here. So this is just going to...
Ooh, that's a little tricky. Okay.
It is a little tricky, yeah.
Okay, so when it doesn't go, like say the 10 doesn't go into the 6, right? So would you then use the multiplication to figure out how many times the 6 will go into the 10? Or maybe I'm confused.
I personally do that, yeah.
Okay.
It's going to be... Okay, so this is... It's going to keep increasing, right? Like the mod until it divides evenly. This is not going to divide evenly, so this is going to result in a 5. The 6 goes into 11 one time, and then there's still the remaining 5 left. So that's what this is right here.
Okay. All right.
A
Now that
question.
Yeah.
Worry about if we are using larger volume, larger numbers.
Larger numbers, it's still like sorry, like what do you mean?
Yeah, let's say we use 125,
Okay.
6.
So this is still actually going to evaluate to 5 because 6 goes into 125 20 times, and then you have 5 left over. Oh, sorry, wait, hold on. Let me,
That's
yeah.
correct. Uh-huh.
So yeah. With modular division isn't really used too much. You'll find that it's very efficient in certain situations, but I wouldn't worry about it too much here. It's very we do need to know this though. Like, that's for sure. So I just hope this makes sense here. We can do so. All right, we'll do this. This is gonna evaluate to 0 because 6 goes into 120 20 times, and there's no remainder. It divides it equally. 120 divided by 6 equals 20 with no remainder. So if it divides evenly, then the remainder is always going to be 0. If you guys have any questions on that, please feel free to just ask. All right, so let's do, for now though, let's do some exponents. Let's see what happens here, right? What's gonna happen here, right? This is kind of uncharted territory. We have the exponential operators here, but it's occurring multiple times. This is going to evaluate to 256. And that doesn't really make any sense, right? But if we break it down, we're going to say, okay, let's break this down into 2 parts. We have 2 to the second, which is just 2 times 2. That's a 4. Oh, sorry. Let me put this back together here. It should be 64 though, right?
Me
Like, we
learning this is
have,
number. Yes.
Because
sorry.
I put that in there. I put that in my other compiler, and I don't know how I came up to like 512 for the two, then the 2 asterisks, then the two asterisks, and the 3.
Oh, that's very interesting. I'm not
Or
sure why
maybe,
that
hold on.
is.
I think I have a 3 in the middle and a 2 at the end.
Oh, I see. Okay. So we're not really expected to figure this out right now, but yeah, this is weird though, right? Like 2 to the second, that's a 4, and 4 to the third, that's 64. Why isn't it saying 64? Why is it saying 256? So the result is showing that the exponentiation operator is using a right side binding. So I thought this was going to explain a bit more, but let's see. I'll explain. So what we're gonna do. We're gonna take a break. It's currently 9:10. Just come back at 9:20, then we'll come back to this, and then I'll explain exactly why that's happening. So we'll see you guys in 10 minutes. just come back, continue. And yeah, we're just gonna pick up right where we left off with the question here. Why does this evaluate to 512? Sorry, my mic was down. Intuitively, this should, we would think that 2 to the third, right, is 2 times 2 times 2, which equals 8. And 8 to the second is 64. Why doesn't this equal 64? Why does it equal 512? Well, the answer is due to a very niche situation in Python, which is called right side binding. The normally so any expression would evaluate left to right, but because we're using exponents here, it's actually going to evaluate from right to left. So it's going to do, instead of 2 to the third to the second, it's going to do this right here, that block of code, which equals 9. And it's going to say, oh, okay, so I want to do 2 to the 9th. So that's 2 times itself 9 times, which would give us 512. Like I said, it's incredibly niche. But yeah, it's something that we should all know. And again, it's called right side binding. There's also parentheses, which we should be talking about as well. So we know that right side binding exists, but what if we use parentheses here? What would happen? I'm sorry. Let's do it like this. This is going to equal 64. That's because parentheses, they take precedence, they take priority over exponents. So it's gonna read from left to right now. It's gonna read from the parentheses first, and it's gonna say, oh, what's in the parentheses? An exponent. It's gonna do the exponent, so 2 to the third, that's 8. And now it's gonna go outside of the parentheses and ask what's 8 to the second? That's 64. So that's just one way in which parentheses can completely change your expression. An expression, what is an expression? I keep saying that word a lot. It comes up a lot, but an expression is a combination of values or variables, operators, function calls, whatever you want, which are evaluated and result in a value. So one example of an expression would be 1 plus 2, 1 multiplied by 2, 1, etc. Operators are the special symbols or keywords that are capable of operating on values and performing mathematical operations. So for example, you have the asterisk, that's an operator. The asterisk in this expression is an operator. Arithmetic operators in Python, such as addition, subtraction, multiplication, classical division, always return a float. Oh, sorry, that's just for the division. Modular division, it divides the left operand by the right operand and returns the remainder of the operation. But we already know that. So yeah, those are all arithmetic operators. That's the whole point of this. A unary operator is an operator with only one operand. So it's something. So for example, it's -1 or +3. There's no division, there's no subtraction, there's no multiplication. It's just this. That's what a unary operator is. Unary just means 1. Binary, an operator, is an operator with two operates. So 2 operations basically. So 4 plus 5 or 4 times 5 -1 plus 3, -1 minus 3. That's binary operator. Some operators may act before others. This is called priority hierarchy, which is what we saw in this example here. We had the exponents acting before on the right. Yeah, exponentiation operators use right side binding. So this is 256 here because of the right side binding. There are expressions and then there are sub-expressions. Sub-expressions are expressions within expressions. We actually already saw that. This whole thing is an expression. Inside here, however, this is a sub-expression. So to figure out this whole expression, you're gonna have to first delve into the sub-expression. This would result in 8 for this. Moving on, however. We're gonna talk more about variables here. So what are variables? We've already seen that you can do arithmetic operations with numbers, add, subtract. This will be done so many times. I mean, you're gonna use it every single time you program, honestly. But it's normal to ask how the results of these operations can be stored so that they can be used in other operations and so on. How do you store results and then use them again? We already saw this. We use a variable. It's a box. You can basically refer to it as a box that contains something, a container. This, again, this is an example of a variable right here. This is a variable name. The variable name is num. Num is a variable. Variable name is fractional here. The variable name is name here. And these are all variables. These boxes or containers, they contain something. This contains a string. This contains a float. This is an integer. If you want to name a variable, you can't just name it anything you want, sadly. I can't just do... that's not going to work. That's going to give me an error here. Because there are certain rules, there are certain conventions that you have to follow when naming a variable. If you want to name a variable, you have to understand that the variable must be composed of uppercase, lowercase, digits, and the character and the underscore character. Variable name must start with a letter, so it cannot start with a number. We had this before, which is not right. You can't do that. But if we put the numbers after, it's fine. It works completely fine. The underscore is actually considered a letter, so we can have this. This is completely fine as well. So case, such as uppercase and lowercase, is treated differently. A little bit differently than in real life. Alice and Alice are the same, but in Python they are two different variable names because of their cases. Variable names cannot be the same as any of Python's reserved words. We'll talk about reserved words a little bit more. It's, to put it simply, it's just special words that Python doesn't want you to have access to. So we can't, pretty sure we can't name this. No, we can. Yeah, so the same restriction applies to function names as well. I'm not going to talk about functions today, I believe, but actually no, yeah, we can. This is a function. You can't name this. If you were to create a function, you can't have the function name be that. So it follows the same rules as variable names. Python also allows you to use not only Latin letters, but specific characters from other languages that use other alphabets. These variable names all right here, these are all correct. I don't see why you would ever do that. I mean, unless you're programming for an international company, but normally you use English when programming. That's just how it is. So this is an incorrect name. Does anyone know why this is an incorrect variable name here?
Because it starts with a number.
Yep. It starts with a number, exactly. Always going to be a big no-no in programming. Also, one more thing that they actually forgot to mention here, cannot use spaces in your variable names. It has to be one cohesive word. You're always going to end up with an error. This is fine because there's no spaces in between. So yeah, let's look at some keywords here. We're going to talk about reserved words right now. So these are some reserved words right here. These are words that are incredibly important to Python. So they want to keep them for themselves. They don't want you to use them unless you're using them for the proper reason. They don't want you to name your variables any of these. So if I try to name my variable if, I'm going to get an error because I'm using a reserved word. And yeah, the list goes on and on. There's many reserved words, but so as we saw before, we can put mostly anything inside of a variable. We can put data types inside of variables. Variables are very powerful. They can be used to store any type of values that have already been that we've mentioned, and many more actually, which we haven't explained. The value of the variable is what has been put inside of it. So the value of this variable is this number. It's pretty simple. Does anyone have any questions on this? All right, awesome. So let's do this. What's going to happen here? What is going to be printed right here on the fourth line?
Would it be 101?
Yes, it would. Yep. So this just means that you can actually write expressions inside your container. So we can put, well, anything. We can put 2 times 100. It'll be 200. And that number is going to be stored always within number. But if we do this though, if we do print number right here, it's going to say 200 here. Sorry, 1 second. Print number times 2. That's going to be 400 because 200 times 2 is 400. What happens if we print number again after this? Are we going to get 200? Are we going to get 400? What's going to happen?
We'll go back to 200.
It will go back to 200. Yep, that's precisely right because we haven't set number to anything with this right here. We were only telling it to print number times 2. If we wanted to set number to another value, we would do this. We would declare it. We do number equals number times 2. So this is saying number is now going to equal whatever it currently is times 2. So we had 200. We said, okay, number is now going to equal 200 times 2. And then we're printing that out. So number is now 400. So yeah, so we just did this. When using variables, you're allowed to use as many variable declarations as necessary. So this is what's called a variable declaration. We're in this line, we're declaring that there is a variable, and we're giving that variable a value. So we're saying, okay, this variable var is equal to 1. Account balance is equal to 1,000. Client name is equal to John Doe. We're gonna print. We're gonna put the var, account balance, and client name, and we're gonna print var again. So what should happen is it's gonna print 1,000, John Doe. On the next line, it's gonna print 1. That's pretty simple. Or sorry, pretty self-explanatory. Does anyone have a problem with this so far? Because
It's fine with me. I do have a question. It might be a little off subject, but what's the difference between an argument and a string if the argument is in between quotations as well as the string?
I'm not sure. Well, okay, so we have this. This is an argument right here, right?
Okay.
This is also an argument right here. This is an argument right here. An argument is, uh, in this example, what's inside of the parentheses here. A string is a value that's inside quotation marks. So this is a string, and then these are arguments that we're putting in.
So arguments refer to parentheses and strings refer to quotations.
Yes, most of the time. It's easy to get them confused. Our arguments aren't values though. Just want to, just want you guys to know that. Because you might run into problems with that later on. So yeah, these are all arguments. And yeah, this is a string, which is a value. Yeah, so we did this already, but I'll just go over it again. How do you set a new value to a variable that has already been created? All you really need is an equal sign. Let's get rid of this. We created a number here, but I don't like number. I don't like the number 1, so I'm gonna try to change it up a bit. Number equals 2. Or we can do number equals 2 plus 3, and it'll give us, and number will now equal 5. If one shortcut that I think is very useful is, instead of, if you want to update a variable, instead of writing number equals number plus 1, you can actually write number plus equals 1. So plus equals just means it's going to equal itself plus whatever you have here. So let me comment this out. So we know that number equals 1 here. What happens if we do this? Let me print it out. Number plus equals 10. Let me just get rid of this real quick. Does anyone think they know?
Would it be 11?
Why would it be 11?
Well, I was thinking it was because the number is 1, right? And then,
Mhm.
but the number equals 10 plus the 1, right?
Exactly. It would equal 11. That's it's a very it's a nice shortcut here. So like I said, programming is all about shortcuts. This is a nice one that you guys should absolutely know. It's gonna make programming a lot easier in the future. Now, if you wanted to do minus, number is going to equal itself minus 10. So number would evaluate 2, negative 9. It works with multiplication, so it's going to equal 10 here. Division, all of that. Very, very useful. And then, okay, there's also another one. There is, if we just want to add 1 to any value, we do this, plus plus. Oh, sorry. We'll come back to that. But that is how you do that. I have another question for you guys here. So variable equals 100. We're saying variable equals 200 plus 300, and then we're going to print variable. What is going to be printed now?
500.
500 is right. Yep. And we can do this, we can do this 100 times. We can say just variable equals, and it's going to be 600, 700, so forth, so on. All right. Let's see. So does anybody know about the Pythagorean theorem? You don't have to know it. It's completely fine if you don't. The So the Pythagorean
That
theorem is. So go ahead.
I was just about to say, is that a squared plus b squared equals c squared?
Yeah, yep, that's what it is, and we're gonna program that right now, actually. So let's do that real quick. It's up to you guys. Actually, should we? Let me do this for you guys. Yeah, we'll do this together. Um, I don't want to use this. I just want to. I'll explain in my own terms. So yeah, the Pythagorean theorem is just a squared plus b squared equals c squared. It's used to solve for the hypotenuse in a right triangle, or the diagonal line in a right triangle. But we're just going to see if we can do this here, if we can program that to see if we can figure it out. So we have A and we have B. And we're going to say C equals A squared plus B squared. Um, the square root of that. So this looks a little bit complicated, but we're essentially just writing out that A squared plus B squared here. And we're going to print that value out. So in other words, we're saying, okay, 3 squared, that equals 9, plus, what's b here? What is that? 4? That's 4. So we're doing 4 squared, which is 16. I'm just gonna put this in parentheses to make it a little bit more readable. Just saying 9 plus 16 equals c squared, which 9 plus 16 is 25, so 25 equals c squared. But what if we want to figure out c? We're gonna have to take the square root of c and the square root of 25, and that will give us c. So that's what we're doing here. We're finding out a squared and b squared, and we're trying to get the square root of that. So it's gonna be 5 equals c, and that's what's printed out here. Yeah, definitely feel free to ask questions on this one.
So would
Okay,
C
number.
just be
All right.
the square root of whatever A plus B is?
C is a square root of a squared plus b squared, yeah.
Okay. So we're using square roots when it comes to C,
Yeah,
or to find C.
yeah, exactly. The square roots are represented by this right here, to the 0.5 exponent. So if you want to do the square root of, let me just wish I can comment this out, but let's try to get the square root of 100. What is the square root of 100? It's
Uh,
what times itself will give you 100. Let's
10.
find out. 10, yeah, exactly. All right, this is that's an error there. But yeah, it is 10. So if you want to find the square root of anything, you do exponent and then 0.5. So that's all we did here. I just hope that makes sense here.
So in that it reads when that's still okay. Maybe this might be off, but isn't that ended what is it, integer?
For this,
No, that's not there. What is it? What was talking about earlier? Something about a whole number. It begins with I, doesn't can't think of the name now.
integer, yeah.
Isn't that a whole number?
Yeah, an integer is a whole number, yes.
So would these be like so this what like the 0.5s or I mean or the 4.0 doing I mean are those what with the I guess am I asking are they still called integers in this aspect here?
It should be, it looks like it should be an integer because there's nothing after the 3, but it's a float because of the fact that there's a decimal place here. It doesn't matter what value is after the decimal, as long as there's a decimal, it's going to be a float and not an integer. So if that hopefully that answered your question. If there was no decimal point there, that would be an integer. But because we have this, it could even be this. Sorry. Because oh, you know what? Yeah, sorry. I have a there we go. Because there's a decimal point, it's gonna always equal float. All right, so let me see. We have about 10 minutes left. It's actually perfect. To better familiarize you guys with with what variables are, and different variable types, different data types in Python. We're gonna do this. I'll give you a story real quick. Once upon a time in the land of apples, John had 3 apples, Mary had 5, and Adam had 6. They were all very happy and lived a long time. End of story. Your task now is to create the variables. I was gonna get lost in translation here, but let's do this. So assign. I'll give you this too, because you're gonna need to know this. So the first step is to create the variables John, Maria, and Aiden. Assign values to the variables. The values that we want to assign to those variables are going to have to equal the number of apples that each person had. So John had 3, Mary had 5, and Adam had 6. Once the numbers are stored in the variables, print out the variables on one line and separate each of them with a comma. So let's just do. Okay, let's do these here real quick. Let's do these 3. We can it's up to you guys. Do you guys want to do this together, or do you want to just do it separately and then come back in 5?
Do we have enough time for do only just 1 or 2?
I'm sorry.
Do we only have enough time to do 1?
You can I mean, if you we
I
can
was
do
gonna
it.
say I was gonna say if we could do the first one together, then if we was to do another one, then we'll be able to have we'll be able to try our own then.
Oh yeah, sure. Okay. Yeah, let's do number 1 real quick. So number 1 is pretty simple. Just it says just create the variables John, Mary, and Adam. These variables, as I said before, they're containers, but these variables don't contain anything. They're empty. So what we want to do for number 2 is assign values to the variables. How do you assign a value to something? Equals
Cool.
the values must be equal to the number of apples that each person had. So we remember John had 3, Mary had 5, and Adam had 6. And then that's all I'm gonna give you guys actually. Just let's see. I'm gonna give you a couple minutes to do this, and then if you guys, whoever has it, just let me know and you can share your screen. We're doing number 2 and 3, by the way.
I think I have it. We're just as far as creating the variables for John, Mary, and Adam. Or not
Yeah,
creating the
but
variables, but I guess John, Mary, and Adam would be the variable, and then the equal would be the number of apples they have.
yep,
I don't know
yeah,
if that makes sense.
exactly.
Okay, so that's all we're
Yeah.
doing. I did that. If you want me to share my screen.
Did you do number 3 though?
What's number 3?
So once the numbers are stored in the variables, print the variables on one line and separate each of them with a comma. So I can let me give you an example of this. We're to say John we're to say John's apples, and then we're gonna give it we're to say that many apples, and then put a comma here, Mary, and the same thing with Adam. So that, I know I kind of like gave it away, but that's how you would do number 3. It's a little bit of a tricky one because of the commas that you have to use. But yeah, who thinks they have it? I'll give you guys another few minutes here. But yeah, like I said, just let me know when you guys are done. All right, so what do we have? Does anybody have anything they'd like to share? Did we do number 1 and 2? Okay. So do you guys do you have any questions about this if you didn't do number 1 and 2?
No, no questions about 1 and 2.
What about number 3?
Yeah, definitely questions about number 3.
Okay, yeah. Yeah, go ahead. I'm here to answer.
I guess my question is, actually, hold on. I think I figured it out.
So let's do this. Let's just do this together. And then if you guys have any questions at the end of this, please let me know. So number 1 was simple. We created the variables, right? We created John, Mary, and Adam. And that's how you do that. Next, for number 2, we're going to assign values to these variables. We can't just have them be empty forever. And the value is going to be equal to the number of apples that each person had. As it says up here, John had 3 apples, Mary had 5 apples, and Adam had 6 apples. So that's all we're doing for number 2. once the numbers are stored in the variables, which they are, we're gonna print the variables out on one line. So we're doing this on one line right here. And we're gonna separate each of them with a comma. Line 4, let me see. So what this line is doing is it's saying it's printing everyone's apples out on a line. It's gonna print out John's apples, right? And a space, followed by whatever's in variable John. So 3. So say John's apples 3. Next, it's gonna go to Mary's apples here, and then print out whatever's in that, which is 5, and then Adam's apples, and then print out a 6. Does that make sense with you guys? What we're doing here?
It makes sense now that you showed us, but I guess when you actually doing it on your own, I understood everything up until 3.
Yeah. Yes.
And I
3.
did forget, I guess, about it.
Yeah, because I'm
Is
getting an
this?
error on mine.
Oh, you are. You want to share your screen?
1 second. Are you able to see?
Yep. You can see perfectly. Okay. Let's see.
So as far as the first two, did I do those correctly?
First two are yep, perfect. And then we have here invalid syntax.
And I saw
Perhaps.
this. I don't know if this is what a semicolon or excuse me for, but I saw that you put those in
Why
when
does
you were
yeah?
doing
Why
it.
the semicolon?
The colons are just for. It's just saying there's gonna be something coming after. That's just You don't need to have a colon there. It doesn't affect the program at all.
Okay. Does it look just
Yeah,
look cleaner or
it
just
looks
help
cle
separate?
exactly. Yeah, it's just to make it look cleaner. That's what I like doing. So the reason you actually have the, and it says it right here, invalid syntax. Perhaps you forgot a comma. You put you should put a so right after the first string you should put a comma. So right after John's apples and before John, you put a comma. Right there. Yep.
And would I take this comma away?
Oh no, because yeah, these are all different values that you're gonna be printing out. So in between, you're gonna put commas in between each value. Right there. And then you do have the last one too, actually. So let's see what happens when you run it now. Nice, awesome.
Thank you.
Yeah, no problem. Does everybody get that though? Do we understand that? Let me share my screen again. Yeah, so I'm not gonna keep you guys here forever. This is optional. If you guys want to do this, it's totally fine. If not, um, you guys are free to leave. But there is number 4, number 5, and then you have a bonus. So if you want to challenge yourselves a bit, I'd recommend doing these. I will put these. Hopefully this looks clean. I'll put that in the chat for you guys. And yeah, just feel free to like just play around with these and see what you can do with different values and of the variables.
And
It's basically asking you.
before you, yeah, I'm sorry. Were you about to go into as far as what 5 is asking
I mean, I could. Yeah, 5. You said. Oh yeah, I was. Yeah.
on what you just printed the extra?
Yeah. What do you have a question about 5?
Well, it says print the stored value in total apples to the console. So I guess just as far as the total value, would that be, I mean, just like us adding all of these apples?
Yeah, so that's what I think that is going to be. Yeah, that one's number 4. So this is what I'm gonna do. I'm gonna give you guys some homework tonight. You're gonna do number 4, number 5, and then if you want, you could do the bonus. There, I would like you guys to find out more about the exponents as well. So like exponential expression like this. Just on your own time though, just try to mess around with this with the double asterisks and see if you can reliably figure out what the results are going to be. Same thing with modular division. So like just mess around, do something like this, see if you can understand what it would be before you actually print it. But besides that, that should be it. You guys are free to go. Please do 4 and 5 tonight though, and the bonus obviously if you want.
All right, thank
All
you.
right. Yeah, I'll see you guys tomorrow though. If you don't have any other questions.